executives like you who would be a really great asset for today's class. Hope you understand the necessity of revisiting statistics, and also I sincerely hope that you should understand the challenge of a teacher covering statistics in RM class, where statistics cannot be covered in totality. And for two reasons, you don't need all, and many of you know all. So that's why what I have to do, I have to selectively touch upon the essentials. And at the same time, I have got a request for all of you. Do stop me where you feel we should discuss in detail, because I do not know the specific need. As we started today, some of you suggested that they have some idea on some chapter, less idea on other chapter. So I do not know. So it would vary from participant to participant. So knowing that all of us have some average idea on statistics, I'll be just trying to touch upon the essence, may not be in detail all, but my objective would be to have sufficient real life examples to have a feel why we need statistics, why we need statistical tool, and how to use which particular tool when. That would be our purpose of today's discussion. So here you go. I've got a structured presentation which I had circulated earlier. As you can see, it's just an appreciation class. And this is actually part one of data analysis. And here we'll have a statistics primer. Towards the end of the session, we'll have a elementary data analysis using Excel. Part two will have advanced statistical analysis, particularly multiple regression analysis. And part three will have SPSS-based data analysis. And I'll be just telling you in advance the roadmap, what we are supposed to cover. Today, we'll be just covering fundamentals of statistics and particularly descriptive statistics through cases. And that would form my part one of data analysis class. Next class, as I was suggesting, we'll be covering predictive statistical analysis, where we'll be covering some multiple regression models analysis, and that will be forming my part two of data analysis. There, of course, we'll be touching upon covering the concepts of testing of hypotheses. And once we appreciate this descriptive and predictive statistics, I would feel that we should be in a position to appreciate a good case, a detailed case. And this case, I would request you all of you should go through very carefully. I'll be supplying after next class, Jim survey case with the data that will be handling in SPSS software. Okay, so as Sudarshan, Dev, and others were suggesting, we come across huge data in our life, maybe in our research in future, and we need to process data. We need to summarize, and we need to get the essence. And for that, the processing is almost synonym to not exactly data analysis. We're trying to make out why we do the processing. As they were suggesting, we try to make out the data, try to understand when you are getting raw data, huge data, what it tells. So that we call ingest information. So now let us reposition ourselves, all of us as a researcher. We'll be collecting data for our research, and research data will be trying to extract some information. It could be for testing purpose, it could be for decision-making purpose. I think some of the basic concept definitions, what we all know better, will not be wasting our time. And data is nothing but facts, figures, we call statistics. And it could be quantitative or qualitative, which we have already covered, discussed clearly. Data can also be in another angle classified as primary data or secondary data, which we have already also covered. Now this, I think I would like to discuss. We often have to handle some databases, huge databases. It could be offline database, it could be online database, and it could be real-time online. I would take a pause, and I would love to trouble my favorite student, Sally. Would you like to comment quickly? Do you find any difference between online data and real-time data and real-time online data, or all the same? Let Sally start first, or you can say pass, and others volunteer. You can raise your hand, those who would like to comment.
Online the data, like the data that are available in different online sources. Real-time online data are day-to-day data that is happening. So I'm not sure. So first of all, I'm not sure. I feel real-time online data are the timely data that we are getting. That's it. So,
any other volunteer would like to supplement, differentiate between the Vikas?
The online data are secondary data. Sometimes the data is maybe correct or something. It may not be correct 100%, but we will get some data through online. That is, we may call it secondary data. In offline data means generally it may be primary or secondary.
Over to Vikas, followed by Priyanka. Quick.
So, Professor Subudhi, I believe real time. I would agree to what Mr. Behra and Shelley mentioned about online sources. So there are multiple online sources, content available. Real time online could be examples like podcasts, which are constantly getting revised as we speak.
Wow! All of you, please note. All of you, please note. I think Sally was not clear. Correct. Sally, by the time Vikas completes and Priyanka takes over, please share your screen. I am enabling you to share screen. Type nscindia.com, your favorite topic. Over to Vikas, please. Sorry.
Yeah. So I was just mentioning that, I was just stating that multiple online sources these days, which are constantly reinventing themselves and constantly upgrading their content. So which is possibly what real-time online sources could be.
Okay. Priyanka, take over.
I think Vikas had a good example, but I'll still go and try. Online could be more about how many boys versus girls born. Real-time online could be I'm trying to check it in a space or a city which is not completely automated. And offline could be over the 10 years, how many boys versus girls born in a city.
I would like to take over Priyanka and Vikas. Be very clear. So that's what I have taken over. Dev, sorry. Yeah.
Yeah, if I can share. So as you're taking the example out here, if you're talking about how the market has behaved in the last 15 days, 20 days, 1 year, pre-budget, post-budget, the data is available already, right? Which is the online data through an online source. But if I open the NSA today and see how the Nifty is behaving now, right? Which is the real-time data.
Thank you so much. Salute Dev. Salute Dev. Priyanka, Sally, try to take the essence of suggestion of Dev and Vikas. I would like to correct Sally and others also. Please remember, real-time data is changing, volatile. Say, for example, reservation status when you are booking a train ticket in IRCTC. Okay, so you were waitlisted, say 57, now it comes down to 17. So it changes frequently. So it's a real-time data. When you are booking something, your position is this much. So now I would take just one of the example for the scholar, those who will be interested in finance, maybe like a huge database like stock market, where you have got like thousands of shares traded every day. Today is not a trading day. So what Sally is suggesting, I think next time I would ask Sally, You have to show the huge database of these companies, and I will help you. I will work with you also as a co-worker, and you will see how the price changes of Reliance, TCS, whatever. So it is real time changing. Similarly, when you are booking, say, for example, a train ticket, by the time you make payment, your position might have changed. Has anybody felt that? Yeah. Say, for example, you saw only one seat available in a train. By the time you make payment, I think you are waitlisted. Have you faced
Yes.
that?
Yes,
So this
sir.
is the real time you're changing. Okay. So
So
now
we can say it's a live data which we get from the
exactly.
sources.
So the researchers can possibly handle all variety of data. Okay. Do you agree? So as a researcher, we must understand the types of data, and this is one of the best examples. I think we'll not be wasting time because I have got hardly 70 minutes, 80 minutes today. I have a lot of things to do. So NSC is one of the example. I'll take over next time. Sally, you have to remind me. I'm not wasting others' time. You can stop sharing. Allow me to share this slide. Okay, I hope having discussed that, it will be very clear. Priyanka, you have anything to say, please?
No, this is clear, sir. So, but just like a birth rate is also real time, it's changing.
No, what is the database?
Population index?
No, online real-time database. If you want to cite one example, like I told you,
Like
say
movie seats in a web app, right? That could be another real
you
time.
see something now, next second it changes.
Correct. So the seats
So,
in the cinema hall.
say for example, say COVID vaccination. Okay, say how many people are getting vaccinated. Every second it changes. Okay, maybe like thousands of centers, people go and get vaccinated, and it is recorded. I think then and there. I guess I don't think it's real time, but it's I think a good example of batch processing. As Sally has joined computer science department, she would appreciate. It's not real time updated. It is, I think, a batch processing case. Okay, let's not enter, Priyanka. Hope I have answered you. Can you
Yes,
please
sir.
remove your hand symbol? Okay, moving faster. So then we process the data. Repeat the word the data. It could be offline data, online data, real-time online data, and for the desired information. And that information, how do we decide what information we want? Yeah, are you getting me? You should read my mind. Anybody who is in sync with me? Any quick input? Because
Yeah, I will just want to. I'll take a database, real-time database like the flight status, right? It keeps on changing while the ETA keeps on changing. So you take a decision on departure or arrival basis that particular real-time database.
no, actually, my question was what exact information? When we're talking which information, I think I hope that you got my mind correctly that it should be in research parlance, a research objective. If you wanted to know this, accordingly, you have to have that kind of information. I'll be giving example. Just wait for 5 minutes. Automatically, this question point will be answered. I've got sufficient example today. So, Dibya, yes, please.
Sir, like I want to know whether the train is running on time or not.
Okay. So, so what is the data? What is the information?
So we can search the data is available whether the train has crossed the station on the time or not. The
Who are
previous
you?
station.
Who are you? Who are you? Don't say I'm Dibya.
And the and the
Suppose you are East Coast Railway traffic in charge. Okay.
Yes, sir. Okay, sir.
Your objective would be which train running on time? What are the trains running late by how many minutes, how many hours? Okay. So that's why in that context, I asked who are you? I know that you are Divya. Don't say I'm Divya. I think Shelly, those who have attended my class, they may be knowing, I often ask in my class, who are you? Okay. So you are the decision maker. You are the researcher. What is your objective? So then you are handling a real-time database. Okay. Railways have fantastic real-time database. They track each and every train at every station, huge database. So from that context, I was asking, who are you? So you are referring to a database, you have got data and specific information you wanted, so that how you will be processing. I have examples. Say, for example, this student database, right? Say, for example, you are director. This is something like almost useless. You don't have time to go through this. Suppose we wanted to know, these are the students who joined us this year. How many people have work X? How many people are senior, not freshers? How do I know if I just have a table like this? Say, for example, please remember, last year, this is actual data of School of Management. Suppose in 2020 batch, suppose the freshers are 139, having 1 year 86 like this I have got. Why I'm showing this? I am trying to convince you this is a simple frequency table. A frequency table can be also taken as a beautiful example of an information, because it is informative, not the last table. This is handy, this is informative, and this speaks volumes. So what we have done, we have processed, we have converted to a simple frequency table. So I'm going to tell you in the next slides. So in statistics, the first chapter is tabulation frequency table. All of us should appreciate the importance of frequency table. Frequency table is also part of data processing. And if you put it, and this is quite informative. And somebody was suggesting graphs. And yes, if you put it further graphically, it's much better, or put like this. Okay, I think it is self-explanatory. Previous slide, we had simple, huge raw database. When you are converting to this frequency table or graphs, it carries better meaning. I think that's what they, because wanted to say us from corporate experience like this. Example number 2, COVID data world over. Okay, so this is what we see. I think it is less useful because we cannot comprehend what is happening. Say, for example, in Odisha, where it is like very acute. In the first phase, those who belong to Odisha must be knowing, it's not Khordha district or capital city of Bhubaneswar, it was Ganjam, which was really a cause of concern. So if you put a graphical presentation like this, it speaks volumes, and the attention concentration goes here. So because of the migrant issue here, a lot of people came from Gujarat and other cities, and it was in the red zone, not Khordha, not Bhubaneswar like this. So this is more informative than like this. Okay. So in a nutshell, information should simply be informative, and you should solve a problem. Okay. Even as one figure, single figure can also be called as an information. Say, for example, how many testing per day, what is the proportion of positivity of COVID virus, and what is the fatality, say 2% die. Okay, so these are numbers, percentage, and can also be called as information, not data. Okay, as I was telling, a small table, a graph can also be called as an example. Going further, as you study a statistics book, we have got averages. Of course, we'll have a lot of examples, and we need averages to have some idea of central tendency, central value. But on an average, what happens like this? So very quickly, I'll go through some of the key concerns about the key informative statistics in question form. What information I need that I should know, why I need information I should know, And how do I get those information from the raw data? I should know. For that, we are discussing statistics today. Okay, and what types of data or information available to me for my purpose, for my research, that should be clear to me. Okay, now this I won't waste your time. This is what my first exercise in QT class, statistics class for MBA students. I sincerely hope at least some of you might have gone through the PPT which I had circulated today morning. The last line is the purpose, objective written. The purpose is looking at the raw data. This is how we collect research data. If we want to infer, understand which is group of buyer most frequently buy our product. Now, before asking you to answer quickly, no calculation, let's not waste time. We'll be covering and switching over to next slide after just 1 minute. Anybody from corporate world, can you please help me us? What is the relevance? Why should we study like this? What is the benefit of understanding which age group is the most frequent buyer of our product? Satish?
So once we know which is our customer segment who buys what product more than others, then the marketing and the service.
Wow, got it. Thank you. We can focus better. Now let's come down to statistics. How do we do this? Sally, because you were once upon a time, some 50, 200 years back, you are a student of mine, so I have liberty of troubling you.
Sir, we can either note down in the Excel, then we can sort the data. We can find the age group, and we
Just
can
simply tabulate it. Okay, put in a table, right? Range and these are the age. Put it in a
table. Then we can put in
you can
the
put it.
range.
Okay. Now, actually, our purpose is something else, so I am not giving more time on that slide. Similarly, another example. So hope we understand. Any quick take, anybody, just to save time. We should not waste time on this. What should we do? When I'm asking what should we do, I'm expecting from you which statistical tool we should apply from the book of statistics.
Average sales.
Very good.
Sir, average.
Should I do it row column average or row average or both? Anybody finding the
Row
difference between
average.
Column
The
average.
row average.
what is the difference meaning implication of row average and column average?
So row average is for the individual, column average would be for the team.
No.
Or just
The
the
row would
reverse.
be for
Only
the
by
row
for the
would be
week.
for the week.
Just the reverse, Satish.
I said the reverse, I'm sorry.
Yeah.
Apologies. Column average is for the individuals and row average.
So my request to all of you is just to have a feel why you are doing this and what is the meaning of row average, implication of row average, meaning and implication of column average. Suppose, for example, 1 week, one executive is not doing, next he or she may be doing better. So you are finding the average performance of that executive, that is the column wise. So entire workforce on an average, how do they perform? So you can have idea as a chief of those persons, okay? So this is how we think of having average, think of using average here. It came from you, I'm happy. So we have not covered here. So now this case we'll be discussing after 2-3 slides. Deliberately I will skip this, but very briefly, maybe one of you or some of you might have gone through this. Any quick input before I give you some input from my side? What is the issue here? Okay, I think I could have given time. This is actually the scatterness dispersion of the workload. Uneven workload means today your employees have got a lot of work to do. Next day they do not have. They just are sitting idle, when your employees are sitting idle for days to come, that's an issue that you are not understanding your office workload, whether you should have more workers, employees, or less employees. So that's what the issue. Actually, the simple answer would be find standard deviation. If standard deviation is higher, then it's an uneven workload issue. If it is less, I think the staff should manage. We'll discuss a bit later. I'll be taking up once we cover dispersion. This is what like hints I had given. I think I was asking Sally, expecting that Sally should have gone through the slides here. So this were the tally sets we should have done, a simple frequency. Now, what is the meaning of relative frequency? Relative frequency, we should know, is a ratio of frequency, individual frequency by total frequency, okay? Now, the last line, please read. Now we have luxury of using so many electronic devices. Earlier, particularly when we started our research work, there was no computer, no mobile, okay? No electronic device. So in those cases, we manually entered in pen and paper and finally put tally sheet like this to make a frequency distribution. Please remember. So this is the background of frequency tables, which one should have. Okay. Even also in smaller towns, cricket matches, those who attend physically, those who might have seen the scorer, how the scorer is noting down. So he must be like finding the tally sheets. The scorer must be maintaining like this. Okay.
Yeah.
So this is the previous stage or early stage of preparing frequency table. Okay. Now here we go, the actual chapter of statistics. Now in first part, we'll be discussing today descriptive statistics portions of statistics book. By descriptive, which is different from predictive, which we'll be covering in the next class. Those are the fundamental statistical tools, starting with tabulation, which I gave examples. Tabulation means you get huge raw data, not in order. I gave example of Maruti sales and Sony example. So it is in random order. You put it into frequency table. Also our student admission database. Okay. So frequency table to start with, and you can also have graphs, percentages. I think some of you have correctly suggested me. This is part of our research analysis and part of descriptive statistics. Each and every PhD scholar essentially should have these two in their doctoral thesis reports. Neha, can you quote my last sentence and interpret what I told?
Sir, these two descriptive statistics.
To Hanuman Chalisa there at your
No,
home?
sir. No, sir. These two descriptive statistics should be included in all the research.
Why?
Research.
Why? Don't
Sir,
quote verbatim. Tell in your own words.
So because it is by seeing a tabulation.
Have you thought of your research topic?
Yes, sir.
What is the topic?
So tribal entrepreneurship.
Okay.
I'm not.
You will be surveying many tribal entrepreneurs.
Yes, sir.
Should there be like a demographic profile, like gender, income,
Yes,
kind
yes.
of thing?
Yes.
Should you have frequency table?
Yes, sir. It would be easy for any layman to know
So,
by looking the tables.
whenever you are presenting your thesis, what I am suggesting, it is essential, common example that we must have these two initially, right? All of you agree?
Yes.
Then, as we all felt in that Maruti Nexa example, I'm happy that it came from you, that many times we'll be needing the use of averages. We'll be giving example. Now, the averages can help us taking a decision, which is better, which is not better, or the like. So all the statistical tools are used to take a decision. Please remember. Now, next in the chapters, we have got dispersion. Dispersion means that, as you understand, synonyms could be the degree of variation that happens among the data. And in that context, we try to calculate variance, which is better represented by standard deviation. And we also try to measure scatteredness of observed data. Okay, I think many times we try to observe. Suppose I can give n number of examples. Suppose somebody in agriculture, Sudarshan Babu, will be say applying or studying the effectiveness of fertilizer on agriculture, say paddy. Okay, as we all understand, even the soil fertility is same. You have got different plots, 10 plots. You apply same quantity of fertilizer. Finally, the total harvest will not be exactly the same. There will be some variation. You agree with me? So what is the degree of variation? If the degree of variation is within some limit, then it is okay. If the degree of variation is very, very high, uncontrollably high, that refers to the means it's an unpredictable situation, which we can again recall that uneven workload kind of thing. We don't know. Suppose we expected I am applying this much, should I get this much or not? We don't know. So I have got inputs. I don't have any say, control, judgment about the output. What will happen? Okay. So those things are really difficult situations. So that's why many times researchers try to understand what is the degree of variation also. We'll be giving example. We'll be giving. Please wait for me. Sometimes correlation, simple correlation is also taken as descriptive statistics measure. Correlation regression should also be used as the predictive statistics also. This is something like a common in both descriptive as well as predictive statistical analysis. Please hold on. We have got a lot of example, and please have your doubts if you have. And as I was suggesting, will be not discussing or wasting your time on how it will be calculated, calculation part. Rather, we'll be devoting more through examples, why it will be done, when it will be done. When I've got so many options, should I use this or that? Why? So those things should be clear in our mind. That should be the objective of discussion. Okay. Now, very briefly, this I would like to skip. The averages we know. I think you know this mean, geometric mean, harmonic mean, median, mode. I think you have got different formula and the approximate relation between mean, median, mode. All those things, I think one can Google or refer any standard statistics book. Will not waste each other's time. Better from application side, hope many of you might have gone through the PPT. If not, please have a look to this one. Through this example, we'll try to appreciate either averages or dispersion or both. I'll be asking which one and why. Neha, can I trouble you again? What is my last sentence?
So we will know how dispersion, what we will
My
use.
question is, I'm going to ask you all, you have to have a feel and be clear. Is it from is it from dispersion or both? But the big question is why. All of you should understand. Okay. Yes. Anupriya, look to the frequency curve. The graph is called frequency curve. First bit question, be quick. We have got less time, hardly 50-60 minutes. We have to hurry up. अरे डियर बोल तो नहीं तो पास करना.
So pass, I will pass here.
Yes, that's a better answer.
Okay.
No,
Yes,
Sudarshan,
sir.
then Satish. First bit question you are answering. And one of the answer is pass. Don't waste time.
So to me, this looks like C could be the answer because as
No. We are trying to answer bit by bit. I am at first bit A. We are discussing first bit.
okay.
Any volunteer?
Sir, I would like to answer the first bit A, which has the larger value. I think B has a larger value. Why?
Simple. I think all of you are scared. Are you thinking that you are again back into the +2 or graduation teacher and stupid Subudhi there? You need to participate, open up. Looking at the graph, can you make out this is what we are discussing? Priyanka, you are there or not participating or having your lunch?
No, I was trying to find the hand to raise, but by that time I think Arpita answered. So yeah, so B is the answer from my side as well.
Surely.
Is it a bounce or going above head or have you understood?
No, sir, I'm getting it.
Then why you are not answering? Anupriya, why you say pass? Second bit.
Yes.
What is the meaning of the second bit?
So I think that it's curve A.
What is the question?
So is more likely to produce a small value than a larger value.
All of you
As
agree
the-
or anybody would like to differ? Satish, is it okay?
Yeah.
Thank you. Move to the third bit.
I would suggest A, Vikash here.
A, sir.
Wow, that's a fantastic question. I like that question. That's why I'm presenting it. Can anybody understand why Vikas is very confident selling A? Can anybody understand?
Sir, I think because
answer?
so I think because because sir has told A because the frequency level here is little high and then it has come down. But I am suggesting for B as it has covered.
No, Arpita, you are a serious statistics professor.
Because there's a peak in the curve A, sir.
Real life example discussion. What is the case?
Vikas said A because he no longer goes to rock concert.
Satish, good one.
I like that.
I think Arpita is not getting it. Okay. Priyanka.
And I still believe I sit in A, sir. That's why I agree with A. I still go to the rock concert.
Arpita, are you enjoying getting it? What others are telling or not?
Sir, I am very, I am enjoying it, but I could realize I'm very much, I should take a back seat in statistics and I should let Vikas lead it.
Are you really talking of statistics? No, I'm not from statistics. I'm not talking statistics today. We are talking about a concert. Arpita, you understand what is the meaning of rock music?
Yes, sir.
Why Priyanka told because he is not into that group?
So might be Priyanka ma'am is having her own answer for this.
No, Arpita, you are not getting, you are not enjoying this. What we personally believe, rock music concert are enjoyed more by the youngsters. You are not getting. Look to the figure. Try to appreciate the figure. Okay, Vikas was very much correct in explaining us beautifully that graph A, where you have got a peak at the lower age. So the average age of the participants of rock concert music is less, younger. So that's why the answer is correct A. Try to understand this. We are not talking of statistics. Don't worry. Statistics, we are not discussing today. We are discussing common sense. Okay. Is that okay? Let's move to next. Shelly.
Sir, it's B. For the D, it's B. The distribution of times patients have to wait at a doctor's office. I think it's B.
Okay. Shelly, you are right. Thank you so much. But I'm sorry, it's not correct. Don't worry. I'm really happy I'm with you. Somebody should try to explain the case. What is the situation? What is it? Again, because I would probably please bail us out. Just tell the case, explain what it is. I think Sally has not got the case.
Possibly I'm also wrong, Dr. Subudhi here, because my response also would have been a B.
Oh,
So I would have said A because when we go to a doctor multiple times, then the initial times we take more time to
why
discuss.
others are not participating today?
Last time.
I think Rimple, are you busy otherwise having a beautiful lunch today?
No, sir. Just trying to understand.
Are dear, try to understand the case. Why we're discussing all this? This why part is more important, not the formula calculation part. This is how, if you get a random topic in research, you need to understand what I'm doing. Then only you can think of a proper appropriate statistical tool. Okay. Sally dear. Suppose you or me critical. Suppose I am critical. Okay. You are my daughter. You are taking me to a hospital to a doctor. Okay. So doctor is busy, but he is famous or she is famous. Okay. So will you not be concerned how quickly I'll be getting appointment? You are waiting outside.
Yes.
So this part picture B is you never sure. Sometimes quicker, sometimes longer. I'm a critical patient. Graph A suggests most likely in a shorter duration will be called and doctor will attend us. Patient's waiting time, try to understand. In part B, you do not know. So are you not discussing here dispersion? So try to understand the meaning, implication, importance of studying dispersion. It is not average. We have gone beyond average. Suppose average wait time here is this, say 40 minutes. Average wait time here is say 30 minutes. That is not enough. In the next slide, you will be more clear. It is most likely, see in graph A, the peak is here, lower. Peak is means high concentration of data. Most likely will be called sooner. Am I making things clear or confusing Neha?
A bit confusing, please.
Good,
Okay.
good. Then I'm successful. If I'm able to confuse you, then I'm successful. Sally, have you understood or still more confused?
Sir, I'm still confused.
Good, very good. I'm also again successful. But I'm pretty sure because it's perhaps to some extent clear. Am I right?
No, I'm also not clear because I would tend to imagine Dr.
Everybody by chance clear? Satish, spell me out.
No,
Sorry, it is not clear because the graph A and B, the more space occupied by B. So I could not understand what is A and what is B. If you see the frequency, A is the more frequency. If you calculate the x-axis and y-axis, the space covered by B is more than A. If you think that the frequency of the top of the A, it is the difference of opinion is coming between A and B. So I am little bit confused.
So if I may
Okay.
Sir, I think our objective and your objective is something different. We are looking at a different perspective. Maybe
so. Can I try? If I say the y,
is my screen visible? The laser
yes,
point?
Yes, sir.
Yeah, visible.
So this point is average.
Right.
Correct. Yes, sir.
So situation A, okay, for doctor A, right? So this is the average wait time. All of you agree?
Yes. Yes, sir.
Now, if you are having here
The less average.
Dr. B, is it less weight or more weight?
More weight.
More weight.
More weight.
And this is more dispersed, scattered. Sometimes within 1 minute you are called, sometimes after 2 hours you are called. Now please see in this case, the high concentration here.
Yeah.
Okay. So when we are talking from a patient's point of view, and also attendant of a patient point of view, Sally was my attendant, I am critical patient. So I would prefer this, no?
Yes, sir.
Am I making clear?
Yes,
Yes, sir.
Okay, fine. So let's move. This is how we have to understand. I think this would be better. I think I'm 200% sure Sally will be happy to answer first. Sally, I'm troubling you again. You are there or not there?
I'm reading.
That means you have not gone through the PPT earlier. Anybody who can save time? Quick.
Sir,
The B.
Who told B?
So,
Anupriya. What
I
happened
would say,
today morning?
A for this matter.
Yes, sir.
Anupriya, are you angry today or?
no, no, sir, I'm not angry, sir.
Arey dear, what is the question?
So, if the following two for the district scores for a group of students on two tests, which is appear to be more difficult for the students, A or B?
So less
Sir,
mark.
sir.
Where you are getting less mark?
So, what I realized from
Sir,
this
A.
graph, so that is in graph A, the students are getting good scores, so they are not finding the paper A difficult. So the graph is
difficult means students will not do better. No, marks will be less.
less. Yeah. So
The negative Q.
So your other friends have already told correctly. B. Do you agree? No, still.
B has a negative Q and A has a positive Q.
Oh yes, sir.
We'll be moving
Now,
further. Now, after average, after having discussed averages, as you all know, there are different measures of dispersion. One could be a range, as you may be recalling, range is nothing but the difference between the highest and the lowest. Okay, and mean deviation is the deviation from mean. Quartile deviation, I think you need not worry much. This is the third quarter minus first quarter divided by 2, we call it quartile deviation. But the most frequently used and most robust tool is standard deviation, which will be using the symbol sigma, and its square is called variance, right? So this is the last one we'll be using almost in all our research, and today also we'll be finding in our Excel, okay? This is what here we'll not be wasting much time. Why? That we should discuss through examples. Okay. Now, what we have been discussing here, frequency curve. I gave 3-4 examples. It tells about the distribution of data. Okay. And think Satish or others were telling about skewness. I'm happy. And skewness is something lack of symmetry. Okay, if there is symmetry, there is no skewness. If there is no symmetry, there is skewness. So these are like, I'm sorry for my bad drawing. So please take it as it's a symmetric curve, and some of the non-symmetric would be asymmetric or skewed curve. Skewed curve are of 2 types. One could be negatively skewed, another is positively skewed. Okay, so this is what if one is more flat, elongated, stays towards the right hand side, that is called positively skewed. And similarly, if one curve is more flat, elongated towards left hand side, it is called positively skewed. I can give many real life example of negatively skewed cases and positively skewed cases, but time may not permit. I request you, please think of it, and you can Google also and get real life examples. Okay, this is a bit interesting example I would like to present. My purpose is to tell you something about the auto-generated, auto-reported data. I think we had discussed 2 sessions back. Hope all of you may be knowing this. Okay, so imagine even a small or average organization like KIT even also School of Management. As you may be knowing, we have got 350 odd MBA students. So like first year, second year taken together, we have got 700 MBA students. How they are like disciplined, how sincere they are. If I want to track, I want to know, I can use this data. And if you talk of the employees of KIT University, we are around 2,000 teachers, 10,000 all category of employees. So if you want to know like some say track like the sincerity and their attendance pattern or the distribution, I think this would be very interesting. So I have taken this hypothetical example of my students, how they really enter. Say, for example, all of you have a look, will be moving faster. All please pay attention. Okay. Now, say, for example, these are the days I'm observing in a month, how students are entering my class. Say, for example, my class starts at 9:30 and I expect all of them should come. Anupriya, when?
Before 9:30.
Before. I liked it.
Yeah.
You are before. Okay, not at 9:30, before 9.
No, sir, before
He's
9:30.
happy also, like if his employees are expected to come at 9, he should be happy that if they have come by 9, before 9, much before, right? Suppose, say, for example, let's see, and all of you be careful. And this particular slide will have a quiz also, which I have not disclosed, and that is a surprise quiz. Okay. Now, say, for example, this is what I'm observing, who comes like as early as 9:20, who comes as late as 9:40 or beyond. Suppose, say, I have plotted the actual data observed from my biometric. Say, for example, this is for one student called Abhimanyu. These are hypothetical data. And this is, can I take a call, please? Yeah. Yes,
No,
please.
nothing, sir. No, nothing,
This
sir.
graph shows
1 minute. I'm not completed, Sudarshan. Please wait. So I'll be showing different students' graph. Hope this is understood. Say this fellow comes like this, and hope you mark the name here. Okay. And Sudarshan Babu, I think, is tempted to give us some better answer. Suppose, hope you understand this fellow is better or this fellow is better.
Sir,
The one below.
So the one below 9:30.
Okay, okay. Suppose, for example, this person. Oh, so sorry. One say this fellow. Can you mark?
Yes.
Yes.
He
Sir.
was regularly irregular. Okay.
Yes.
And only one day, when he came to know that Subhadip sir is going to conduct a surprise quiz, he came much early. To utter surprise of all the classmates, he came here. Next day again, as usual. Okay.
Did not go home, sir.
Good one.
And this data, should we consider this? As a manager, as a senior HR professionals, should you also take into consideration when you are taking the average?
No, sir. It
No,
is to the
sir.
data.
Data.
Kind of data also may occur when you are conducting your research. Those are called extremities. Please note it down. And in statistics parlance, in research parlance, we call outliers. Okay. So if you take a socioeconomic survey of one village, very remote village, Sudarshan Babu, I think you'll be happy. In one village, 1 or 2 jamindar will be there. Their per capita income will be very, very high. And others, damn low, very low. When you are taking the livelihood or the economic status of the villagers, if you add one jamindar who is a like man of crores, billionaire kind of thing, that will inflate the average value. that will not actually give the correct picture of the living standard of the poor villagers. If our objective is to understand the living standard of the villagers, I think I would suggest remove that extreme values. And so, for example, you have like applied fertilizer. One patch, I think, eaten by cows, and it's a zero harvest. Will you add that? No, you just remove that. So those extreme value, both sides, should be carefully handled in that analysis. So this is the purpose of giving you one real life example. Okay, so let's move faster so that we can cover the descriptive analysis here. So this is one when we are comparing two persons. Let's not waste time on much data. I can give you huge data. Make it simple. So for example, as you all know, Ajinkya, Ambati, they had a lot of ups and downs, and Ajinkya was in, out, Ambati was in, out in Indian team, and maybe like a third down or fourth down, I don't remember. So Ambati was selected, next time he was not selected, and in a half he retired from cricket. Okay, so now when you are a selector, when you are finding the past performance, how will we selecting Anupriya again? Can I trouble you, Anu? Jaldi bol, or you say pass? What is the question? Who should be selected? You are selector.
Who should be selected?
So when I'm asking who are you, don't say I'm Anupriya. You are the selector. So you have to select only one. Whom should you select? Quick, or say pass?
So I will go for the first one.
Why?
So
Ambati
the scores is consistent.
Ambati has scored 80, very high score.
So actually for 75, then 80, then 10, there's a drastic drop in their scores.
Okay.
But the first one is the consistency. So that's why I will go for the first one.
Sudarshan, quick. Can you answer within 1 minute or less than that? 30 seconds.
My answer is the first one because it is steady in the 40 to 75.
Because please. Kindly, be brief. 40 seconds.
Sir, I would go for Ambati because even if I remove the outlier, possibly the average is much higher than the first one.
Average is equal for both.
Deliberately, because I have given average is the same. To confuse you, average both players same.
I did calculate, but then it appears to be more.
Because actually, your predecessors told, I think Anupriya correctly told word consistency. Right. Sudarshan told correctly steady. Okay, I'm happy that some synonyms are coming from you. So when you're talking of consistency, we are talking of dependability of the batsman. When you are sending the batsman to strike, we have got hope or faith or trust. Yes, he could score something. Okay, sometimes 80, sometimes 10. You don't have any trust, faith. So the consistency factor comes. There you feel the necessity of discussing what is the opposite of consistency, Anupriya?
So consistency is
what
first.
Is the opposite of consistency?
So non-consistency, so inconsistency. It's not consistent. There is a huge drastic gap from one average score to
Can
another.
anybody suggest the opposite of consistency?
It's inconsistency.
Other than inconsistency, some other word?
That may be irregular.
Irregular, okay. Anything else?
Dispersed.
Wow. So Satish has not forgotten that we are discussing today statistics and we are discussing dispersion. Okay. Dispersion, scatteredness, variation, we have already introduced. So the opposite of consistency is that. Okay. So when we are handling a data like this, we all feel the necessity of measuring the consistency or alternatively the degree of variation. Okay, without wasting much time, let me give you the other example. Actually, deliberately I had given 50 each here. Now this I think would be very simple. I think when I'm asking you to look to the two pictures, I think Priyanka, you are there? I think all of you will agree that this yellow,
Right.
I think example would be better.
Yes.
When we are deciding who is better, what we are expecting, what we are judging, Sally?
Sir, we're judging the consistency of the shooter here and more accuracy towards the
Accuracy, consistency, good. Now, if I want to deliberately complicate the issue, imagine there are 20 shooters. You've got 20 such pictures. And you have to name the best shooter. Can you please all imagine the difficulty of exactly knowing who is the best?
So we can
The
see which
highest
is less
score.
scattered.
One by
Correct.
one, Neha, then
So-
Priyanka.
So we can see which is we can see in the yellow picture, yellow one, the points are less
My
scattered.
question here is not two here. You got 20 such pictures.
So which the one which is less scattered is one the better.
Okay. I think you are close to answer, but you are not understanding the real difficulty is same. Can you imagine similar fire
Pictures,
shots are there? How do you compare? Are you getting my point? Dimple, then Priyanka.
Sir, I understand. I am understanding what you're trying to say. When we are right now, we have these 2 pictures, but when we'll have 20 pictures, it will be very difficult. So we'll have to calculate the level of dispersion or variation.
How?
So
The
how?
possibility to transpose all of these pictures one over the other, and then you see where we see the highest level of concentration, that becomes the best
No,
shooter.
fine. You are telling me a good construct called highest level of concentration. But how do I measure? I am, Priyanka, a statistics student. I want quantification of measurement. I want to know that she has this score, she has that score, he has that score, 20 shooters.
we can measure the points from the center, distance from the center.
Wow. This is what
Yes.
I wanted from you. So the distance from the center, which you call bullseye,
Yeah.
okay, all shots, can it not be measured?
Yes, sir. It can.
Okay.
Right, so
This is what I was expecting. So the how part we should understand. Okay. So now say, for example, I got 20 shooters selling, right? So I go on adding the distances and I add for each player, each shooter. Sally is clear?
Sir, yes.
So the person or the shooter having higher distance will be better. You agree?
Sir, lower
Lower distance. sir.
Lower
distance.
distance.
Lower
Lower.
distance.
I was just checking whether you are
lowest-
attentive or not.
That is
So,
lowest distance from the
Minimum
bullseye.
distance better. So
Yes. sir.
from this concept, we are trying to understand present that the variation, scatteredness, dispersion is a negative thing, bad, less the better.
Yeah.
All of you agree?
Yes,
So the consistency and variance is inversely related. Okay, more variation, less consistency. Less variance, more consistency. So from this example, we are understanding consistency and variance, they are inversely related. All of you are clear?
yeah.
Moving ahead, I think this will be repeating. So this is very, very important. But today we will not be discussing in detail because we have other activities today also. Correlation, as you know, or regression, we want to determine the nature of relationship and strength of relationship. I hope that many of you have covered correlation, and I sincerely hope that some of you must be remembering something. Who can correctly differentiate between the two words, nature and strength, what we are meaning? Any guess? Be quick.
The nature is
Student.
either is positively related or negatively related.
Wow, fantastic. The sign, positive, negative relation, nature. Strength means how high. Is it close to 1 or close to 0? Okay. So two things at a time we study in correlation study. Okay, relation is inverse or relation is direct, positive, negative, whether the correlation is very strong or very weak, okay, between two variables, okay. Once we find there is a strong relationship, then we can build a regression model. This will be repeating again. And we have got different types.
Sorry, can you repeat again? So we're saying nature is positive or negative, but strength could be strong or weak.
Yeah, stronger means I will be discussing later.
Sure.
Correlation highest value will be 1. Okay, there is a limit. Correlation value lies between -1 to +1. It cannot exceed 1. So if it goes closer to 1, we will be calling stronger relation. If the correlation value tends to 0, come closer to 0, then we'll be calling it there is no relation or bonding relation is very weak. Am I answering you, Priyanka?
Yes, sir.
Okay. This will be repeating. Actually, this is very, very important for researcher. And last line, all of you note, I would ask you all to make a note, the last line particularly, out of the two variables, when you are trying to correlate, one is called predictor, another is called criterion variable. The synonyms are explanatory variable and dependent variable. Y versus X, okay? X is explanatory or independent variable. Y by default will be using as dependent variable, okay? Let's skip this. I think graphically when you are plotting the data, if the trend will be upward like this, we will be calling a positive slope or positive correlation, or we call direct relationship. If we find a direction like this on negative slope, we'll be calling it inverse relationship or negative correlation. As you know, if one decreases and other increases, this type of relationship is called Anupriya what?
Vice versa.
Vice versa is a relation.
So no sir, either is
a new statistics book or what?
no sir,
You
no
only
sir.
told
Actually,
negative or positive,
yes
and
sir.
we had told another synonym direct or inverse. There is no vice versa term. Shelly? Are they directly related or inversely related?
Sir, inversely related.
So inverse related means what? Negative correlation, Anupriya.
Yes
Okay,
sir.
don't say vice versa. If one is decreasing and other is decreasing, this is called
Directly.
Direct.
and or positive correlation. Same way, if both are increasing, it is also positive.
Directly.
Okay, this is what the explanation. One example could be GPA versus CAT score. Before joining institutes IIMs, as you know, students appear CAT, and after joining MBA, they get scores, which you call GPA. Now, somebody wanted to study those who do better in entrance test. Will they also do better in studies? What is the statement I told, Neha? Quote
So
my last sentence.
those who will do better in CAT score will they study better?
Okay, which will depend on what? Which comes first, which comes next?
So study better.
Out of syllabus question. You can ask me, sir, you are asking out of syllabus question.
No.
Anupriya?
Yes sir.
Yes, sir is the answer.
No sir.
No, sir is the answer. अरे answer बोलना नहीं तो pass कर. Silly.
CAT score comes first, then the GPA.
So which is X, which is Y, which is dependent, which is independent?
CAT score is independent and
Then dependent.
If they are related, if you get dots like this, I had shown 2 slides back can you recall what type of relation you are finding? Suppose the researcher found this type of graphical representation. What we will be calling?
Direct
Direct relation.
Very good. Or positive correlation. Okay. What is the meaning of positive correlation, Sally? Direct or positive means what?
They're dependent. Both are dependent, and one is increasing or the other is also increasing.
If somebody has done better, he or she will do better, we can expect. So this is how we have to understand. All of you clear?
Yes.
Any question up to this?
No, sir.
Okay. If it is understood, then you have to answer me this quiz one by one. Oro, you are participating or gone away?
No, sir, I'm here.
Okay. Now we have suggested few types. Okay. Can you just look at here? D2. Is my screen visible?
Yes, sir.
Yes, sir.
Yes,
What
sir.
type of relation is this?
The negative.
Negative.
Very good. What type of relation is this? B1.
Positive.
Positive, sir.
Positive.
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 Sure.
Yes.
Yes, sir.
Yes, sir, positive.
Sir, I think it's near somewhere in middle of positive, negative, sir.
Priyanka?
Zero.
So
Priyanka?
neutral, neither positive and nor negative, because 2B is positive.
Yes, sir, zero collision.
In definite direction, no? So it is almost scattered. That is very weak relation. We cannot say this. Now, who can comment very objectively and very briefly the difference between these two, A1 and A2? A1 and A2. Because I understand that it is a bouncer ball for you, but I enjoy
One still attempt the ball.
So in A1, I think, sir, with regards to X and Y axis, there is a significant positive relationship between each variable, like the dots representing the variable. There is a
over. Dev, can I try? Do I have
Can I try, sir?
1 minute or no? Dev, do I have permission to trouble you?
I would
Saswat,
say that it is
Arpita, you are
closer.
there or slept? Arpita, you are there?
Yes, sir, I'm there.
Yes, sir. Why you are not responding?
No, sir, my net bandwidth is like it's deflecting, so your voice is coming half.
Your energy level is high, no?
Yeah.
So what is the question?
So the question is the relation between this 1 and 2, first two
Not
graph.
relation, distinction.
What's the difference? The difference.
Yes,
Yeah.
any volunteer?
So can I?
So the
because-
exact change in one variable
Kindly,
is doing the
kindly
same change.
permit because simple. Because
I would suggest that the correlation here is very high in 1A, whereas it is slightly lower in.
wow, that's the correct answer. Pimple, you have got the same answer or something different? Maybe different.
Sir, now I'm confused.
Because you are different.
I was answering. I was saying the change in
So when you
one
got a
variable.
straight line, please
It's a
remember
perfect.
fundamental concept. It is perfectly one.
Perfect.
One. Correlation is highest to one, exactly one. R, small r, the symbol of correlation coefficient small r, Neha, will be here exactly one. And A2, it will not be exactly one, maybe 0.8, 0.7, 0.9 like this. So all of us should try to understand, we have studied correlation. The fundamental concept should be understood like this. By looking at the scattered plots, I should make out, is it giving a stronger relation? Is it giving a weaker relation? Is it giving a positive relation? Is it giving a negative relation? So this is the objective of giving you this graph. Okay. This is what I think Vikas had.
Sorry, one quick question on the previous slide. If one was going in the negative direction, right, a negative slope, then we will say the correlation is 0. Is that what we mean?
No. Thanks for asking, Priyanka. I'm really very happy that you asked a very interesting question. I think Neha should have asked that. Don't mind, Raghavunere. So
Yes, sir.
the negative direction is not 0. It could be -1 also. And negative is not bad thing. As a researcher, please try to understand, if the magnitude amount is very high, close to either +1 or -1, that's a fantastic thing. We should be like telling, wow, we got a very strong relation. If it is also -1, we should be happy that we can make a prediction which will be 100% correct. In the next slide, I'm going to give you example, Priyanka.
Sir, 0 means weaker relationship.
0 means no relationship. If it is slightly more than 0, 0.1, 0.15, 0.2, those are weaker. 0 to 0.4 kind of thing. Okay. 0.5 and above is stronger, 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 and 1 is the highest one.
Yes.
Priyanka, am I answering your question?
You are, sir. Thank you.
Okay. Now here, that's what like as a supplement to Priyanka's query. Now, when you are predicting wind speed, if you remember, I think some of you must have heard of the naming of cyclones, Philene, Hudud, all those things. Okay.
Yes. Yes.
So when Philene was predicted, and please recall, there are many agencies predicted. Indian Meteorological Department, US Navy, and so many agencies. And you will be happy that the prediction accuracy of Indian Meteorological Department was comparatively most accurate. So when you are taking the explanatory factors, what are the factors you have taken? What is the model you have taken? And what is the variation? Okay. So if the explanatory factor have got a very strong correlation, either negative or positive, then what you are predicting will be much more accurate. So this is part of predictive statistical analysis, which we'll be discussing later. As we have started correlation, I'm just suggesting you. Now, you remember the meteorological department had told at Gopalpur in South Odisha, it will make a landfall at this time, at this speed, and that happened. Okay. So the degree of fluctuation could be like 10 kilometers this side, that side. Okay, 200 kilometers per hour speed, and maybe 10 kilometers this side, that side. And the US Navy had predicted it would be like 250 to 300. Okay. So now this is what like the role of magnitude of correlation. Stronger the correlation, if you are using as a predictive model, your prediction accuracy will be very, very high. Okay. These are some special cases. I just told this will be +1. And I think some of you try and self-learn. This is something beyond your research. And maybe like these are some of the things. And we know the method of measuring correlation are scatter diagram method, Gaussian method, and rank correlation method. Don't worry. Now, I think we have got time to make practice for what we have learned so far in descriptive statistical analysis. I think you have all received my sample data, which is GPA data of my students, and we'll be just analyzing this. And please remember, we also try to understand the spirit of the case. We'll be discussing ourselves, what should be done and why should be done. And that we will be discussing the case. Okay. Now,